Hello, Legacy Sabers, Marsh here. So today we're going to talk about how to solve a logarithmic equation using our log properties. You're going to want a foldable today and then maybe a calculator just to do some simple math. So our essential question, how do I solve a logarithmic equation when there are multiple logarithms on the same side? So different kinds of log equations that we have the ability to use. We have logs on both sides. We've already looked at this one. This one's one that we've looked at before. We have the log on one side. We've looked at that one. And then multiple logs on one side. That is what we need to look at today. We haven't looked at that kind of equation just yet. So a little bit of review. Remember, logs on both sides. If I have logs on both sides, remember, we're just trying to make things equal, which means the logs basically can just drop away, right? We can say 4x minus 7 equals x plus 5. Solving, I'll get 3x equals 12, x equals 4. Now remember though, when we're solving a log equation, you do need to double check to make sure that you don't get a negative or a 0 inside of a log. If you do, it's an extraneous solution. So I'm going to do a quick math here. 4 times 4 is 16, minus 7, 9. 4 plus 5, 9. Checks out, no problems there. Now, same thing with a natural log. I have natural log on both sides. I'm just going to make them equal to one another. Okay, solving it, I'm going to get 3x equals 10. I'm going to get x equals 10 thirds, it looks like. And again, I want to plug that in. This would be, 10 thirds is 3 1/3, so this would be more than 3. And this would be still a positive number. So we're still good there. Both of them will not go to 0. Now, logs on one side, remember we had to get the log alone. So I would subtract 8. Divide by a negative, right? Get my log completely alone. And then when we're stuck here, we had to go to exponential form. So we went 2 to the third equals x minus 6. We know 2 to the third is 8. So I'd get x equals 14. And just like last time, we had to plug it in over here. We will not get a 0 or negative inside of the log. So we're all good. That checks out for our answer. Same thing with a natural log. I'm going to subtract 5, divide by 2. So I'll have ln of x plus 2 equals, 5 halves. Kind of disgusting there, but nevertheless. So I'm stuck in log form again, right? So that means I need to find my base of an ln, which remember is just e, which was like 2.72, something like that. Now I'm going to convert to exponential. So I'm going to get e to the 5 halves equals x plus 2. Now I need to know what e to the 5 halves is. So 5 divided by 2. A couple of decimals here. Oops, missed the 1. 825. 0.1825 equals x plus 2. Subtracting 2, I'll get 10.1825 for our final answer. This, plugging it in, definitely does not go to 0, so we're all good there. Okay, now the new stuff. How do I take care of multiple logs on one side? Sometimes you need to condense into one log using those properties. Then we convert to the log. Just remember, again, we have that negative value so that we can't have inside of a log, nor can we have 0, so we should make sure we check all of our solutions. So I have logs, 2 of them, on the same side with a with a subtraction in the middle, right? Subtraction, if you remember your log property, means that we need to change to division, right? So I'm going to condense my problem into a single log with 5 plus 2x up top and 4 minus x on bottom. So all I did is I made that subtraction into its division. Now I'm stuck in log form, so now I get to convert. So I'm going to say 2 to the third equals 5 plus 2x over 4 minus x. This is just an 8, right? And you know what? I'm going to put it 8 over 1 so I can kind of see a fraction equal to a fraction. Just like that. Now I can cross multiply, right? 32 minus 8x equals 5 plus 2x. Solving, I am going to get 27 equals 10x. So x equals 27 tenths. So 2.7 roughly. All good here. No negatives, no 0. This one will also be okay. So we're all good there. We've checked our solutions to make sure that it is okay. Let's try another one. So log base 4 of 2 plus log base 4 of 4x squared equals 3. So I have addition between two logs, which means if I condense, it would turn into multiplication. So I'm going to get log base 4 of 2 times 4x squared equals 3. Technically, this is just 8x squared, right? So I'm going to do a quick erase job here. 8x squared. I'm just going to change my math so I don't have to write it again. I'm stuck in log form. Let's convert. So I got 4 cubed equals 8x squared. 4 cubed is 64. Divide by 8. I'll get x squared equals 8. Square root both sides, right? Don't forget, we do have that plus or minus, and we'll get 2 root 2 for our answer. Now, 2 root 2, close to 3, 2.7, something like that. Looking in my answers, both the plus and the minus is not going to cause either of them to be 0 or negative inside of the original log problem. So we know both answers do in fact work. We actually got 2 answers for that one. Ooh, this one. I have subtraction in the middle, but before I do that, do you see this 2 sitting right here? And I can't just divide by 2 because then I would get a division by 2 over here on this ln. That would be gross. So what we're going to do is we're going to take this 2, we're going to go and put him back because the power property says if you're doing 2 times a log, you can make that number an exponent. So I'm going to make him back to be an exponent. So this guys will just be x squared. Okay. Change that. Subtraction means division. So I'm going to get x squared over 5x minus 6 equals 0. Stuck in natural log, so I'm going to go to exponential. My exponent, or excuse me, my base on my ln is e. So I'd get e to the 0 equals x squared over 5x minus 6. E to the 0, anything to the 0 power is 1. So I'm going to get 1 equals x squared over 5x minus 6. Technically 1 over 1. Do some cross multiplication here, right? X squared equals 5x minus 6. Get everybody on the same side. I know, it takes forever. I know you saw it happening, though, because you're like, oh, I bet we're going to have to factor. And you're right, we do, because, you know, I haven't factored in a while. X squared minus 5x plus 6. So I got to set my factoring out. I'm running out of room here, people. X, 3 and 2. Because I need them both to be negative to make a negative 5, but a positive 6. So I'll get answers of x equals 3 and x equals 2. Let's double check, though. So if I plug 3 in to both of these, we're going to be good. So that one's an okay answer. 2 works in both of them as well. So both answers are good answers. Oh, look at this one. So this one's kind of a weird problem because notice the logs are not on the same side. But I can't do anything to make this not have logs on both sides, right? Or logs, I can't condense. I can't divide because there's 2 here. So I can't just drop the logs because I have that 2 minus. So what I'm going to do is actually I'm going to manipulate this problem so that I have logs on both sides. So I'm going to make this ln of x plus ln of 5 equals 2. I'm just going to manipulate this problem so it looks a little different. Now I have addition, so now I can multiply. So I'll get 5x. It's 5 times x, right? Convert to exponential, so I have e squared equals 5x. Ooh, what is e squared, Mr. Calculator? E squared is 7.3891 divided by 5. Oops. Marsh messed up on our calculator here. There we go. Answer of 1.4778 for an answer there. Plugging it in, definitely not going to be 0 or negative. Definitely not 0 or negative. All checks out there. No problems there. And our last problem, this one's a big 'em, people. So first thing I see is I have a number in front of a log. So I'm going to go and put that up to being its exponent again. So that way I can condense this beast, make it not look as scary. So this would be log of, well, that's squared on both people, right? So that'd be 9x to the 4th. Because I got to square him and square him, which multiply those exponents. Minus log of 2x squared minus 1. All right. I got some condensing to do, so I'm going to subtract this. Notice I'm just kind of letting this log over here on the left just kind of exist because I'm going to see some. I see something happening in this problem, and I kind of wanted to see what's going to happen. So I'm going to condense the right-hand side. I'm going to make that into division, just like so fashioned. Now notice what we now have. We have log on both sides. Oh, how exciting. We can make the logs drop away, right? So I'm going to get 5x squared plus 4, I'm going to put him over 1, equals 9x to the 4th, 2x squared minus 1. Got to do some cross multiplication. Yuck, right? But hey, that's what happens. It's better than having to do multiple log properties because we could have moved this log of 5x squared plus 4 all the way over there and then we had a double fraction. Ooh, no one wants to deal with that, right? So I'm going to get, I'm going to go 9x to the 4th. I'm going to do the cheap one easy. Okay, foiling 5x squared plus 4 and 2x squared minus 1. I will get 10x to the 4th minus 5x squared plus 8x squared minus 4, it looks like. Condense that right-hand side here, make it a little cleaner. Oops, that's a 4. Plus 3x squared minus 4. Get everybody to the same side. I'll get 1x to the 4th plus 3x squared minus 4. Factor. X squared, a 4, and a 1. Positive 4, negative 1. So I'll get 0 equals, that factors one more time. X squared plus 4 doesn't though, right? So I'll get x equals negative 1, x equals 1. This guy, we're going to do a quick little side note. X squared plus 4 equals 0. I'll get x equals plus or minus 2i. The imaginaries are coming back, people. Plus or minus 2i. So now, I got to check my work here. Do all of these 4 answers possibly work? So plugging in negative 1, I'm going to get a positive. Here, I'm going to get a positive. Here, I'm going to get a positive. So negative 1, all good there. 1, definitely positive, definitely positive, definitely positive. 1 works. Now you're probably thinking, Marsh, Those i's cannot work. Okay, let's check it though. So if I plug in a positive 2i into this squared, I would get 2i squared, which would be, because if I did this, right, beep, plus 4, I would get 4i squared. I squared is just a negative 1, right? So this is technically a negative 4 times 5. So this is a negative 20. Plus 4 doesn't work, right? Womp womp. And if I do a negative 2i, we're still going to get the same problem. So plus or minus 2i, even though it was so cool to use imaginary numbers again, does in fact cause imaginary solutions. So, or extraneous solutions, and also imaginary, I guess. But does not work. We cannot use them. So negative 1 and 1 are our only answers to this problem. And that is the end of this video. I hope you enjoyed solving with your log properties, and I will see you later, Sabers.